Hello, my name is Stijn Rommens. Thanks for joining and welcome. In this session, I'll be introducing Vectra AI, who can help in early detections of threats before they become a breach, in today's networks, as well as in the ones from tomorrow. And the ones from tomorrow, or we also call that the digital transformation, is ongoing since many years. But it has never been accelerating as quickly as in the past few months due to the COVID-19 emergency situation. Companies have been enabling more remote access, but they have also been building additional applications, services, as well as workloads, quite often in public cloud. This, of course, has also had an impact on security policies. Additional investments have been done towards the endpoint by deploying EDR technology, but also the access to resources has been hardened by enabling more VPNs and by activating multi-factor authentication. Despite all of those actions taken, a lot of attacks still happened in 2020. As such, Vectra AI, we believe that detection and monitoring capabilities has been important and will be important going forward. And this is all to do with the security gap that still exists. Yes, we have been investing a lot in preventive capability, but it has also created a false sense of security. Because I think it is fair to say that the companies that have been breached did also invest in the types of technologies you can see on this slide. Still, they had an issue. The supply chain attack, or for instance, adversaries are also using end-to-end encryption in social media, allowed them to land in the network. They could take control of a machine, could collect credentials, and could progress into the data they wanted to steal or to plant the ransomware. As such, if we are not investigating and investing in continuous monitoring capabilities, we will not be able to close the security gap. Let's plot the SolarGate supply chain compromise onto this. I think it is clear to all of us that the initial compromise was coming through trusted software, and it impacted potentially 18,000 organizations. Yet, it was bypassing all of the security mechanisms in place. And so, once the attacker could establish his tunnel out, he had full access into the network, partly because a lot of the preventive technology is not in the network, despite zero trust implementations, but also because he is acting like an administrator. You could say he's living off the land. He's hiding in plain sight, creating additional rights, setting up trusts, and moving from on-premise into the cloud to exfiltrate the data. So if you're not investing in AI-driven detection capabilities, both on-premise and integrated with cloud, you will be blind to this and future attacks. And that is why Vectra is investing so much in AI-driven NDR capabilities. We want to close the security gap. And we do this by building technology that is looking at attacker behavior rather than at initial signature-based indicators of compromise. So by building that quality of detection, we are also reducing the number of alerts and improving the quality of the individual alerts. This will give the time to the analyst to investigate and to bring back the time between infection or a threat and breach and remediation. So the mean time to remediation is drastically reduced. So how do we do it? How do we make this a reality? We do this by still collecting the data as we did from day one from the network. We look at the raw network data and can collect it at different places in the network. But at the same time, because of that shift into digital world, we also are looking into the log files from a lot of the cloud providers. What has not changed is that we are still using one methodology, and that is that security research will keep on looking for techniques, tactics, and procedures an adversary could use to penetrate into a network. And once they kind of found and proved the technology, they're going to hand over the data to the data science team. And they will look into how to build a model for this. And this is an AI-driven model, not purely based on mathematical Bayesian models, but also, for instance, looking at neural networks, etc. And with this one methodology, we can still come to real-time detections, which we enrich with a lot of data that can help the analyst to come to conclusions. And this is the platform we use for that. Cognito Network Detection and Response is a platform that is built out of a couple of components. The one the user and the analyst will see most is the brain component. That is where the interface is running and is the one that is connecting with the underlying components. And the underlying components like Cognito Network for Detect is Cognito Detect for Network, I must say, are virtual or physical appliances that can be connected on switches, taps, or packet brokers to collect the raw network data to deliver it into that brain. But we also can use Cognito Detect for Office 365 and AzureAD to connect into the cloud. All these detections come into the same brain where the analyst is working from, and he has access even to PCAPs when it is network-based detections. At the same time, a lot of the analysts, of course, is looking into more proof of what has happened around the time frame of the detection. Since we already took a fingerprint of all of those relevant connections, we can forward these into a metadata lake. And that metadata lake can be either hosted by you, and for that, we will use a connector Cognito Stream to transform the metadata into BroZeek format, or you can leverage a service from Vectra. It's Cognito Recall, a stack in the cloud that is integrated with the Detect platform. As such, the analyst now has the full detection capabilities, as well as the hunting and forensic investigation tools with the metadata lake at hand. As such, what we also can do is bridge the cloud with the network. We have seen in SolarGate that there was the transformation from the network into the Office 365 environment to exfiltrate the data. By building a relationship between the identity and cloud, typically the email address, with the identity of a user, typically from Active Directory in your network, we can bring all of those detections and identities together. We will score it in a single user view. This is quite unique, and it will help you to also protect your network in the hybrid environments we live today. The Vectra difference is that we do make that bridge. We make that bridge from cloud to network and the data center. But we also reduce the number of events that the analyst has to work. This has a positive impact both on the SIEM as well as on the workload of the analysts, and it will give them time to react. On top of that, by allowing the integration with additional tools like your existing network and endpoint capabilities, we can also enable automatic responses. But what is mostly important is that we are not relying on signatures. We are building attacker behavior-based detections that will help us to focus on the real threats in the network. On top of that, Cognito allows to be integrated with your entire security stack. It is quite possible that you already have a SIEM or a service that you take, and that you would like to correlate all of the data there. On top of that, we also would like to make sure that you can integrate with orchestration tools and or, for instance, endpoint detection and response capabilities. On top of that, if you would like to steer responses, investigations, and remediations, we can also enable the API capability. And we have a lot of options to do this with the technology that you might already have in your network. And this will be a true integrated detection and response stack. As such, Vectra stops threats before they become a breach. And we would like to give you also a good insight on what this really means. For that, let me end the show here and move into my interface here that you have normally open. So where's my mouse? Looking for the mouse. There we are. What you see here is the interface of the Vectra Cognito Detect platform. And what I'm focusing on right now is the host view. And in the host view, as you can see, we have actually a few components. We have a quadrant, and in that quadrant, we have actually a threat score and a certainty score. For that, we can plot the hosts based on its threat and certainty scores in it. As such, the analyst now can focus really on the high and the critical quadrant in order to find the threats in its network. What we could do is also use a couple of the filters, which I'm going to do right now to look for the critical detections. As you can see, and of course, this is not a realistic simulation for a network. We should have this almost empty, but in a demo, I would like to have a couple of examples at hand. And one of the examples that I'm looking for is the Orion server in this case. So as I explained in the presentation, the SolarGate component was a multitude of events in the network. And this also gives the opportunity to a network detection response capability like ours to have multiple touch points, and we might be able to find it quickly. And this is exactly what we see here. In this case, I can see that on this server, we have actually had a detection profile named external adversary. We have found multiple indicators of a threat that this was taken control by an external adversary. And this is what you can see here. At the same time, I can also see that this machine has been targeting a machine that I already classified as a key asset in my organization, which is the administrator machine of my administrator in this network. And this is what I actually can see here. In this case, the lateral movement was already addressing this machine. What I also can see is the timeline of the events, what have happened. And so what I could do right now is to go and look into a little bit of detail. What I can do here is look at the different steps that the attacker has taken. And as you can see here, he has built a couple of items, or he has done a couple of items. First and above all, he has enabled persistency. He has built a tunnel, and I can tell you where the tunnel was going to. I can even go into a couple of details, and we can see why we fired off this detection. So we give you some information. You can also find information about what this threat was, so it can even help you to understand why this is firing. And we give you also the summary of this detection, even the big details. If we could collect the JA3 and the JA3S hash, which is a fingerprint uniquely identifying the client and the destination, we could give you that as well. But we also can give you that this is not looking like a normal SSL session. It looks like multiple short TCP sessions, typically also used for command and control, right? So this is the type of things that we can connect here. What we also see is that from that same server, the attacker has also been trying to enumerate information from the network. So he's been looking around, he's been asking the Active Directory, in this case, called through LDAP, what users potentially are there, and we can see the objects or the number of objects that he could retrieve from that environment. On top of that, we also can see that from the reconnaissance phase, we also have RPC recon. And RPC recon is often indicating that the attacker is trying to use a credential and is testing it against other machines. Can I get there? Can I log on onto these machines? And with this type of detection, we can help the analyst again to give them an indication of what is potentially happening. Here, there's a reconnaissance on testing the credentials, most likely. And then we see this execution against our target that we are also monitoring more specifically. And if we look in here, what we can see is that this attacker right now has been using a methodology to get onto the administrator machine and has been registering their task. This is most likely to create some persistency on that system. We also can see that the service account was used here from this machine was in play. From now on, we were probably going to look into a bit more detail of what could have happened on that machine. And by looking here, we can start to see the things that are not just purely based on network packets. We also look at the behavior of the accounts, the services, and the machine. And that is why we have a privilege anomaly detection here of an unusual trio. And the unusual trio in this case means that we have detected that a combination of the host, in this case, the compromised Orion server, with the admin account using a terminal services service has never been seen before, or is very unusual, is not expected to see on this machine. This type of detection typically gives you a good indication that an attacker is progressing into the network. We give you even more information. We talk about why this is unusual for the account as well as for the machine. We also give you what would be the expected machines or services that would use this type of service. On top of this, as I explained before, it is also important to not just keep track of what is on the network, but also start to look into what potentially could have happened in the cloud. And the link with cloud is not an IP, but the link with cloud is an identity. And that is exactly what we have here. So the identity of the administrator will give us now the opportunity to start looking also on what has happened in Office 365 or even Azure AD. A lot of this is actually related to Azure AD. And what we can see here is that we have actually a cloud account as well as a network account that have been stitched together. And we can also find out, based on our integration with LDAP, that this one is part of the domain admins group as well. So we have not only seen the detection, we have also been able to give you a lot of enrichments straight into this interface. And we also can see many of the different attacks phases involved. So the link between the network detection and the Office 365 or cloud detection was this anomaly detection. And what we now start to see is that the account can also access, and let me open them up very briefly or quickly here, so we can come back on these. In the movement to the cloud, we can see that this account now has been trying to log on onto our Active Directory, Azure AD, and Office 365 infrastructure from a location it was normally not expected. And we can give you also that detail. It is similar to sometimes what you can find in Office 365 directly, but here it is immediately in a correct way displayed. That's one. But two, there is also the additional detections that we correlate back to this account. And that is often what you cannot find in the traditional Microsoft security tools. So what we see here is that with a threat of 67 and 34, so it's quite high, that we see that this administrator has been setting federation settings on the domain. And we also give you on what domain this has happened. On top of that, he has also been creating redundancy, so creating additional credentials that have been linked with a specific activity service within the environment. On top of that, what we also see is that there has been an exchange transport rule that was created. So in this case, we can see that if there was something sent to IT, that there will be a blind copy also to the attacker. And in this case, we can see that the collection of the data is already happening. Finally, what we also discovered in the SolarGate approach is that there were searches using e-discovery. And it's very hard to do this with security tools in Microsoft to a detection. And so we see here, for instance, that the attacker is looking for source and patent information. And he can do that by using e-discovery into the entire Office 365 environment, including SharePoint, Teams, etc. And what we also figured out is that there was a Power Automate rule created to exfiltrate actually the detections of that shared discovery via SharePoint into the Dropbox environment of that attacker. So we're looking by looking into both the detections for an endpoint as well as the correlated information to the administrator, we could bring back a full chain of attack into this environment. Of course, the goal is that we should not see all of those details in the Vectra console by alerting and acting as an analyst much more quickly into the beginning of the phase. And that is also why our hosts dashboards uses those attack behavior profiles, but also the colors as well as the criticality. By a few detections already, it would be in the critical quadrant so that the analyst would have been looking into that machine. So for now, I thank you for your time and I hope to meet you again soon. Thank you. Bye-bye.